Welcome friends, welcome to JCE Connect. Today we are going to derive the third derivation, and here we are going to derive the height h based on the ground coordinates, based on the ground uh, coordinates, that is capital XA, capital XB, capital YA and capital YB. We know that we use these terms in the last derivation and we derived the equation to determine the length between A and B, that equals to square root of xa minus xb square plus ya minus yb square. Now all these things will be there in the derivation number 2. I'll show you those those ground coordinates and that distance of distance L between A and B. Now if you see this figure, that the distance between A and B can easily determine if you know the XA and XB. And how to get that? See, that is square root of XA minus XB whole square plus YA minus YB whole square, that equals to L. Once if you know the coordinates, you can easily get the L, and once if you get the L, then it is very easy to determine the H value. Now this is what we are going to derive. Now this is what we are going to find out H. What will be the distance between the exposure station and datum line? This we call it as what? Height of lens, right? Height of lens from the above the datum line. This is what we are going to derive. Now here see, if the image of 2 points A and B having the different known elevation and the known length between them appear on the photographs, right? So length is known and elevations are known. So these are the known things on the photograph. The elevation of a height h of a exposure station can be calculated by reverse procedure from that of preceding derivation, that is derivation 2. As proved in the derivation 2, the ground length L is given by, now this is how it is given. L is equal to square root of xa minus xb square plus ya minus yb square. Now your intention is that this equation you are supposed to have in terms of h. Now this, if you want in terms of h, then you should require, now you should put the values of xa, xb, ya, yb. Now to get that, see, first you have to remove the square root. How to remove the square root? It is very simple, that just get a square length square. L square is equal to xa minus xb square plus ya minus yb square. Automatically that square root is going to be vanished out. Now substituting the values of xa, xb, ya, yb, we can obtain the whole equation, or you can terminate this whole equation, right? This equation in terms of h, that we are going to see what is xa, xb, ya, yb. Now in derivation 2, what is xa? That is xa is equal to h minus ha divided by f into small xa, and ya is equal to h minus ha divided by f into small ya. Similarly, capital xb is equal to small capital H minus small hb divided by f into small xb. Small capital YB is equal to capital H minus small hb divided by f into small yb. In general, this is the formula for x coordinate, this is the formula for y coordinate. Now if you put these values here in this equation, right, so you are going to get the h, because here you can see that in all these values you will be having h. H is a common term, so that you are supposed to put there to get the height. Now here I'll be adding those values. You can see that L square is equal to HA minus capital H minus small ha divided by f into XA minus capital H minus small hb divided by f into xb. This is the second term, right? Whole square plus h minus ha divided by f into ya minus h minus hb divided by f into yb whole square, right? So these values I have taken from the derivation 2. Now I'll be getting the h value. Now in this equation, the ground distance L and the elevations HB, HA, HB are known quantities. The photographic coordinates like small xa, yb, small xa, small ya, small xb, small yb can be measured. The only unknown is what? H. Now this is only unknown is H. The collecting term of H, the equation can be taken it as, no, you can convert that whole equation into the quadratic equation, that is ph square plus qh plus r. Now these terms I have taken, p q r I have taken for the no for the understanding purpose, for the simple understanding. Now this whole equation you are supposed to convert into the quadratic equation. Now that can be in the form of, see, you can convert this form of, say, I can write as ph square plus qh plus r. Now this r is going to be l. Now this second term it is here, and first term you have to create that. So all these terms you are supposed to create means you are going to get the quadratic equation. This whole equation you are supposed to write in the form of quadratic equation, then only it is possible to get the h value. Now I have converted this what I can write. Now here you can see that no collecting the terms for which quantity is taken for the quadratic equation will be this, whereas p q r are the numbers obtained after the substituting the values of known quantities. If you substitute the all known quantities, whatever things will be remain, those we are going to consider them as what, p q and r. The values of the values means you are supposed to, put the all known values, then you are supposed to convert that into the form of quadratic equation. Then you can write that quadratic equation here like this: h is equal to minus q plus square root of q square minus 4pr divided by 2p, where this p q r are the numbers obtained after the substituting the values of known quantities. Now this is the derivation number 3. This is what from my side. I am Professor Balasar Jamadar. Thank you.